Now, critical minerals are the building blocks for the energy transition and the new industrial revolution. They are in the batteries, microchips, magnets, and even the wires that are core to electrification and technological advances. And they are largely extracted and processed outside of the United States. A report from last year from the US Geological Survey found that the US is over 50% dependent on 21 non-mineral commodities and another 21 critical minerals for suppliers outside of the US borders, and 100% import dependent on 12 critical minerals. So quite a lot of exposure across the different technologies that we'll be hearing about today. And how will that change going forward? By 2035, demand for these resources is expected to increase drastically with electrification and takeoff of technologies that use this. A report from the Carnegie Endowment for International Peace, published last fall, categorized lithium, manganese, graphite, silver, nickel, and cobalt as high priority minerals to develop secure international supply chains around. For those critical minerals we can supply and process domestically in the US, there's an important dynamic around cost to understand. So higher cost domestic production can impact the technologies that they go into. There's a lot to consider here, and we'll dive into it today. We'll start by hearing from Abigail Hunter. Abigail, over to you.
Thank you for the overview of SAFE. Just again, nonpartisan, nonprofit advocacy organization. The Mineral Center focuses both internationally on partnerships with our international allies and mineral producing countries through a unique relationship we have with the US Department of State. And then domestically, we're very tapped into the US policy ecosystem, supporting rulemaking, legislation, and implementation of different policies. So I think you did a great job, Jake, articulating the big picture, but just to drill down a little bit more into why we care. Downstream manufacturing depends on access to raw materials, and without access to them, we cannot run factories and risk becoming the assemblers of the future, losing jobs, investment associated with different advanced manufactured goods like batteries, magnets, but then also the things that they go into like cars, wind turbines, defense systems. Second, expertise and innovation flows from the ability to make changes on the factory floor. So currently China dominates critical mineral supply chains, and that's really undermining our ability to innovate in other places like the United States, because we do not get that hands-on experience. And then finally, we need to remember that obviously defense applications rely on many of the same critical minerals that go into energy and commercial applications. The demand growth for both of these is intensifying. And so it's really important that we are watching the geopolitical challenges in this space that can be used for economic coercion, leading to bottlenecks that could undermine our GDP. So that was obviously kind of the looming scary context, but what are critical minerals used for? How do we kind of make this a little bit more accessible? Right now, energy and transportation sectors are getting a lot of attention for critical minerals applications. Obviously, in EV batteries, you have battery materials like lithium, nickel, cobalt, manganese. You also have permanent magnets that are used in electric motors, wind turbines, defense systems, sensors in cars, the thing that makes your phone buzz when you get a text message, that's a permanent magnet. Critical minerals are used in solar panels and also in the solar frames. So cadmium, tellurium, germanium, aluminum, especially titanium, zinc, magnesium. Obviously, chemistries for all of these things can differ. So this is just kind of the higher demand application considerations. The same minerals also go into the defense sector that go into the applications that I just went into, energy, into transportation. I'm not going to rattle through all of these, but just get a kind of taste of where we see relevant minerals used in fighter jet engines. So the anode of a lithium-ion battery is filled with graphite, but so is kind of that thermal coverage of a fighter engine so that you don't get that thermal signature when you're traveling. Electronic systems that underpin the ongoing digital transformation and deployment of a lot of AI also use other critical minerals. We get a lot of attention on gallium and germanium used in semiconductors here, as well as the permanent magnet minerals that we talked about earlier. You also have a high amount of cabling and transmission needs to fuel these data centers indirectly and directly, and so there you're getting a lot of attention towards things like copper. So you're probably thinking now, Abigail, that was way too many minerals. How can we possibly prioritize these? They can't be all created equal. And so here's a really helpful, if not very intense, graphic that we use to help really anchor our work, and that the US government has been doing as well. So this year's US Geological Survey methodology for the US critical minerals list was adjusted, and they did this really excellent deep report, and we can put in the chat the analysis we did on our report that's titled, "We read the US Geological Survey methodology changes so you don't have to," truly for that reason. But ultimately, they combined many of the risks we talked about at the beginning, the importance minerals for our manufacturing, defense, and technology base, all measured in their impact to US GDP. And then they weighed the probability of a disruption to access to those minerals. So on the far right of this chart, you can see where you had that convergence of a high risk of disruption and a high importance to US GDP, and samarium has that top spot there. So hopefully this is a helpful guide, and again, our analysis can maybe help it be a little bit more digestible in terms of where the US is focusing on the most vulnerable minerals today. So now you understand what we're concerned about, why we're concerned about it, but what are we going to do about it? And under this administration, I think that we can fairly say that they've thrown every policy solution at the problem. Many of these policy tools were leveraged in the last administration and even in Trump 45, so a lot of credit goes there in terms of the legislation and rulemaking that went into making these optional. But this administration has gone even further, a much more expansive policy creativity, particularly on the investment and trade side, in terms of really trying to see what tools we have in the government toolbox to solve our critical mineral dependency, concentration, vulnerability challenges. How are these policies working? One metric we like to use is how the capital market is responding. Obviously, financing new mines, extraction sites, smelters, refineries, chemical processing facilities all come with a price tag, but not one that the US government nor partner governments should pay alone. Private sector finance is a good metric also because they are constantly evaluating the risks of critical minerals projects to make sure that they're capable of investing for a return. So if they're willing to allocate capital to critical minerals projects in any specific supply chain, it's a good litmus test for a defrayment of risks from the government policies that are being deployed. We released a report last year, right before inauguration, that bucketed minerals projects into 4 risk categories: technical, financial, compliance, and geopolitical. We have used those to determine where government support is needed and where gaps remain, and we worked with a handful of investors to be able to do this analysis. This chart is probably a little bit dated, but here is the bucketing of those risk types again, but then looking at the specific policy motives and policy tools across the interagency in the US context that are rallying to create solutions. So I'm not going to run through all of these, but just so you have it, there is obviously quite a long list of policies that are being deployed in different arms of the government to really get at some of these technical, financial, compliance, and geopolitical risks. And the other thing I want to emphasize is that we're obviously not doing this alone. There are many permutations of G7 plus countries who have committed to solving this problem. And in this administration's recent work, you have a lot of, I think, 30 plus memorandums of understanding that have also been signed bilaterally with many of these countries that are focused on making sure that the US is not alone in creating policies and investment streams into critical minerals projects, but that's happening alongside partner nations, that they're also considering their own unilateral authorities like regulations, permitting regimes, and other funding tools. Notably on this slide, you have a lot of continuity of international partnerships. The Mineral Security Partnership, which was started under the Biden administration, has been rebranded by this administration for continuation by Forge, and so quick update there. And lastly, we also have a private sector who is very activated on this problem. We've seen some really incredible supply-demand partnerships emerging. Some examples that I've included on the screen include GM and Lithium Americas. So Lithium Americas is one of these companies that's seen a lot of support from investment, production tax credits, as well as a Department of Energy loan, as well as getting the General Motors to invest directly into the project and have offtake. And so really you see that kind of perfectly triangulated government, off-taker, supply chain, producer, all working together. Another really interesting novel partnership worth touting is Schneider Electric with two of their customers. So Schneider Electric was anticipating the challenges that we're seeing in terms of the rising demand for copper with insufficient supply of new copper coming online. And they work with many different sub-tier suppliers that feed into their digital automation electrification products, but are price takers and are not actually able to produce the copper. But one of their big clients is Glencore. And so they were able to bring together this really unique partnership where they could toll that material through and have a vested interest, obviously, in Glencore's ability to deliver on that because they themselves are selling those technologies. Very similar concept is being used with Torngat Metals, which is a rare earth producer in northern Quebec. And then lastly, we're seeing some of these changes as well in the defense industrial base. Lockheed Martin's partnership with Korea Zinc, focused specifically on germanium supply for their defense and space applications. This is particularly critical because defense contractors are finding it increasingly challenging to get materials out of China. And obviously, with today's concentrations, most mineral supply chains have to cut through China for that processing stage. And so making sure that they're not only working with alternative companies, but they're actually able to source them for their defense applications is quite crucial.